Hello, folks. Now, we've been talking about muscle movement, right? Muscle movement in relation to origin and insertion, and muscle movement in relation to muscle actions. Now we're going to talk about muscle movement in relation to levers. So what is a lever? We usually think a lever is going to be used to move something heavy, and using a lever is going to make it be able to move easier, right? And that is true. But guess what? It depends on how you build or construct the lever. Depending on how you construct the lever, you can actually make things move faster as well, not just moving things that are heavy. So let's get into some examples of different types of levers. We have first class levers, second class levers, and third class levers that we're going to be getting into. But we have to know what a lever system is. So lever is going to be a bone and the joint. And so that muscle is going to generate force using the rigid rod, which is going to be a bone, and a pivot point, which is going to be our joint. And there's three things that are related to a lever when it comes to the bone and joint. First is going to be the load. That means the body weight. So if we're talking about a lever system, we have to be able to have something that, again, is quote unquote heavy, right? And so that is where our load can be. I'm saying body weight, but of course you can think of a dumbbell, you can think of a baseball, anything you want to have in your head. And then you also think of the fulcrum. Now the fulcrum is another way of saying joint. And so that's going to be our pivot point, just like we saw up here. And then finally we have the F. This is where our force is coming from. Remember, muscles generate force. How do they generate force? Using lever systems. So we have the weight, we have the joint, now we need the muscle to apply that force, okay? So where's that? Some folks will be like, okay, where's the muscle? The muscle itself applies the force. No, the thing that's gonna cause the movement when it comes to a muscle is going to be the insertion. So it's actually applied at the insertion of a muscle. Not the origin, not the entire muscle itself, but at the insertion end of a muscle. Because the insertion, the goal is for it to move to get closer to the origin. So we're talking about applying force. We're talking about the insertion of the muscle getting closer to the origin to cause a contraction, or again, apply force. Load, the fulcrum, and the effort are going to be what we use, the terminology we use to understand levers. And of course, we have our first class, second class, and third class. Remember, we said usually a lever is something to make used to make something heavy move easier, right? That's going to be our like a first class lever. So we can say like normally what we think a lever is. Second class lever you can think of as like a wheelbarrow, for example. And again, it's going to make it easier to move something that's very heavy with the wheelbarrow. And the third class lever you can kind of think of as like a catapult. So you have the catapult and you have to put a certain amount of force in order to make sure that weight is being projected off that catapult. So you can think of those in those three different ways. Now let's orient ourselves. Now remember, we have load, we have fulcrum, we have effort. So anytime you see this person here, we're going to be thinking of effort. Anytime you see like this little pivot point here, it's kind of like a cone, right? You see the point here and then you have a cone here. That's going to be our joint or our fulcrum. And then when you see the rock, that's going to be our load. So again, we have the effort here, we have the load, we have the fulcrum, and we have the fulcrum here, we have the effort, and we have the load. And so because of the way these different levers are constructed, we can kind of create little acronyms for it. So for example, first class lever is going to be an Eiffel, like the Eiffel Tower, EFL. That means you're going to have the muscle, the insertion of the muscle or the effort. Then you're going to have the joint itself. Then you're going to have the load. Next is going to be a second class lever, and we can call it ELF, because you're going to have the effort. Then you're going to have the actual load. Then you're going to have the fulcrum. And then finally, we have the third class lever, which is going to be FEL. First, you have the fulcrum. Then you have the insertion of the muscle, which is going to be the effort. And then you have the load. So you can say the Eiffel Tower had an ELF, but he fell. That's the way to kind of remember first class lever, second class lever, third class lever. I'm going to give an example. As we can see here, we have someone's skull, we have their vertebrae, and then we have a muscle here. The muscles are we're going to focus on. So let's think about our origin and insertion. We have an origin here. If the movement's going down, our insertion has to be here. Because again, the insertion is going to get closer to that origin. And the muscle here is the splenius capitis. You don't have to know that muscle. It's not on your muscle list. It's just for example. Okay? Now, what's the whole goal here? The goal is that we're going to be moving our head, which is definitely the load, up. So you can do that now. Move your head up. Guess what? You're using your splenius capitis muscle, and also the load is going to be your head. Now, where can we see our joint? This is going to be our joint here. That's where our fulcrum is. And so I can actually just erase my insertion and origin here and just put E. And what do I get? I see my effort, my fulcrum, and my load. I'm looking at it Eiffel, which is going to be our first class lever. Now, anytime you're thinking of levers, you got to think of two words, advantage and disadvantage. An advantage means that it's easier to do the movement based on the structure of the lever. So it's easy to do this movement of this insertion here, going down to the origin for this muscle, based on it being eiffel. It's going to be easier to do that for the other structures of levers that we have, second class and third class. Well, let's think about it. If I have my muscle here that's going to be moving down, my head, my load is moving up, my fulcrum joint is in the middle here, and I'm moving my head back. Okay? Can this be an advantage? Well, guess what? It's going to depend. Why? It's going to depend on the fulcrum. Where you have it here, the fulcrum or the joint is right up near the load. Yes, that's going to be very advantageous. Because again, that pivot joint is going to allow that load to move, and the effort is also going to do the work as well. So the effort is going to move, or the insertion of that muscle is going to move down, and the pivot joint here is going to allow the load to move backwards. So that would be very advantageous, very easy to do, right? But let's say we move the actual fulcrum a little bit closer to the muscle. Let's say our fulcrum is down here now. Guess what? That's going to be disadvantaged. Why is it a disadvantage? Because it's going to be harder to do a movement based on the construction of the lever. So an advantage is easier to do the movement based on the construction of the lever. Disadvantage is harder to do the movement based on the construction of the lever. So if I change my construction of the lever to where now I have my joint closer to the actual muscle here, then think about it. This whole thing now becomes a load. And that's going to be harder to be able to gain back. Also, you don't have like different pivot point there in between those vertebrae. Not like the atlas and the axis of your cervical 1 and 2. Right? These are actual vertebrae, and so they don't have the same type of movement potential. So yes, that's going to make it a disadvantage. So we can say an advantage is determined by the location of the joint, of the fulcrum. So if it's closer to the load, it's going to be an advantage. That means if it's further away from the load or closer to the effort, you know it's going to be a disadvantage. So just by looking at the second class and third class lever, let's look at this. Is the effort close to the load here? No. Is the effort close to the fulcrum here? The answer is no. You see the effort over here, the fulcrum over here. But here we do see that the fulcrum and the effort is closer. So automatically we know that this has to be a mechanical disadvantage. And this has to be a mechanical advantage, right? So you can think of it multiple ways. You can say, okay, how close is my load to the fulcrum? Or how close is my effort or insertion of the muscle to the fulcrum? If my effort is closer to the fulcrum, disadvantage. If my effort is further away from the fulcrum, advantage. If my load is closer to the fulcrum, advantage. If my load is further away from the fulcrum, disadvantage. So let's focus on E and F. Again, these were further away from one another, so we said that it was advantageous. But if we move that fulcrum closer to it, it'll be disadvantage or disadvantage. Here, our effort and our fulcrum are further away, so advantageous. Here, our effort and our fulcrum are closer together, so disadvantage, right? Now let's go ahead and look at our load and our fulcrum. Load and fulcrum are close to one another here. Good old advantage. If I move the fulcrum here, now my load and fulcrum are further away. Disadvantage. Load and fulcrum here are closer to one another. Advantage. Load and fulcrum here, load and fulcrum here are going to be further away. Disadvantage. So that'll allow you to understand the advantage and disadvantage of these different levers. Okay? Let's go ahead and focus on the second class lever. Now, could we automatically tell ourselves that this is going to be an advantage or disadvantage? Yes. I can look at the load and fulcrum being close to one another, or I can look at the effort in the fulcrum being further away. Either way, I know it's going to be an advantage. Now, we can think of this as a wheelbarrow. If our fulcrum is going to be a wheel, our load is going to be a rock that we're lifting, and of course, our insertion of our muscles here can lift that wheelbarrow and move it to where we need to go. An example for our actual human body is going to be the calf muscles. So calf muscles is just a generic. Of course, we're going to get into the details of the calf muscles, but as you can see, those muscles are going from the insertion towards the origin, and they're going to be moving up. So it's almost like you stand up straight, you put your feet flat on the ground, and then you're going to move or get on your tippy toes. Okay, folks, that's what we're looking at here. That means we have the joint, which is going to be the base of our toe here. That's going to be our fulcrum. And then we also have the load, just right in the middle there. So that load is going to be the weight of your body as you're going from tippy toes to flat, okay? And I always kind of think origin and insertion to help me understand movement. You don't have to. You can just say, hey, I know this is the effort here. So as you can see, it says ELF. ELF means that you're doing the effort, then you're going to have the load, then the fulcrum, and yes, this is going to be a very advantageous, okay, to the movement itself. That means it's going to make this movement easy. So this movement should be very easy for everyone to do, just like the movement of bending your head should be easy. Let's talk about when it's not going to be easy. And that's going to be like that catapult example I was telling you about here. So here we have our load, we have the effort, and our goal is to lift this load with the insertions of the muscle. Let's get an example. Yes, we have our good old biceps brachii again. We have a weight in our hands. So we know that this is going to be the load, this is going to be the effort, and of course the joint is going to be our fulcrum here. Okay? So think about it. Our origin point is here, and then we have, our insertion is here, our origin is here. Our goal is to contract this muscle to where the insertion is getting closer to the origin. So you're going to take that weight and you're going to be flexing it towards your shoulder. You're going to have your forearm and your elbow joint flex, 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 right? We notice, we see the elbow joint, that's the fulcrum here, and we also see the insertion point is right after it. So again, if you're looking at the muscle itself, you'll be like, wait a minute, the muscle is going to be before the fulcrum. No, you have to look at the insertion. And as you can see, the insertion is right here on that actual forearm there. So that's the real insertion. So the joint comes before the insertion. And that's how you get your FAIL acronym. Okay? Let's erase all this just to make sure we can see. That's going to be very important when you're looking at different visuals. Like, here's my fulcrum. The insertion is right here. So that's going to be my E, and then, of course, load. And this is going to be a mechanical disadvantage. How do I know it's a disadvantage? Just by looking at the construction of the lever. The load is further away from the fulcrum, disadvantage. The effort is closer to the fulcrum, disadvantage. So automatically, this is a disadvantage. Now, again, I made sure I said, okay, my insertion has to be over here somewhere, my origin has to be over here, and I'm going to be contracting to go towards that origin. But that can also make you think, oh, this muscle's before the actual joint or the fulcrum, and it's not. We're talking about that insertion point right there. An insertion point right there is where we're actually going to be thinking of the effort being. Okay, folks? Just keep that in mind. And so when you have this kind of FAIL or this third class lever, think about it. This is how most of our arm and leg muscles work. Okay, we have some kind of weight, whether it's your own weight that you're going to be using, or again, you have different weights that you're applying to your leg and your arm muscles to what? Strengthen those muscles. What also can you do for those muscles? You can basically make them go faster, right? So for example, if you're a runner, what do you want to do? You want to be able to run faster. How do you run faster? Well, you go ahead and use a third class lever to get your legs in shape, right? And as you're moving your legs and getting them in shape with an extra amount of the third class lever system, then guess what? The legs can actually move faster and you can run faster. And one way I think about it is like your body is, you can think of your body as a series of levers. And if they're all going to be at a mechanical disadvantage, then they all can compound to one another and make you go faster and faster and faster. So if I have a mechanical disadvantage from, like say, our example here, I'm going to have a mechanical disadvantage from moving the shoulder, the upper arm, and also the forearm, the hands, the fingers, all that is going to cause a mechanical disadvantage. And so the more I'm able to do something like that, then guess what? I'm going to have a greater range of motion. I'm going to be able to move faster as well. And so mechanical disadvantage, you got more effort, but it provides greater range of motion. Okay? Think about those folks who can throw baseballs at 100 miles per hour. It's the perfect example that everyone always uses. You can throw a baseball at 100 miles per hour because, again, you have been first using your third class lever system, taking all those disadvantages of movement to be able to throw something and putting them all together so that by the time that your baseball is thrown out of your hand and it's touching your fingertips, it can go super, super fast. But you need to make sure that you're using this third class lever system to help you work on that. This is why folks go like, okay, when you start using your muscles properly and using different types of muscles, remember, some folks just go in and like, I'm just going to bulk up the biceps brachii, right? And just get it bulk and bulk and bulk. But don't forget, you have those smaller muscles as well, like the brachialis, which still causing that kind of flexion of that elbow. So you want to make sure you're strengthening them, which means that you have to have different types of ways that you're moving muscles. And sometimes some folks are focus on just strengthening smaller muscles versus larger, depending on the stretches that they do, Pilates, things like that. Let's think about it. If you got all these disadvantages, yes, it's going to be a ton of force because they're all coming together, and this is all contraction based, right? But you're probably going to have a lot more injuries as well. So if you're putting, like, again, if you're throwing that baseball, yes, all the disadvantages of your shoulder, your upper arm, your forearm, your hand, and your fingers are going to come together to make you be able to have a greater range of motion and move that ball faster. But you're probably going to have end up having a lot of arm injuries as well. Because again, it is a disadvantage. It's going to be a harder movement to do. So a lot of times, that's why you don't see a lot of folks in sports who are just going into in their 60s or 50s, because at that point, the injuries are all compounding now too. And yes, it's going to be harder to start moving your arm and doing the things that you normally would do. It becomes painful. Let's go ahead and get into an example. Origins of the 3 hamstring muscles are located on the ischial tuberosity. So we see our origin here, and it says origin, so we do have a couple of origins on these hamstring muscles. And therefore, if this is the origin, then my insertion has to be right here. I'm going to just make sure I write a dot and put an I. Okay? The insertions are on the proximal end of the tibia and fibula. Knowing this, what type of lever system is the hamstring a part of when it performs the movement of flexing the knee? Would you expect the hamstring to work at a mechanical advantage or disadvantage when it performs this movement? So they're asking a lot of the stuff we just saw. First, we need to be able to identify where the effort, the load, and the fulcrum is, okay? We just identified the effort, which is going to be our insertion here of this muscle. The load is going to be our foot, okay? So I know that my E is here. And then what else do we have? Our fulcrum, which is going to be the knee joint. And how you label this is going to help you a lot. So we need to make sure we're labeling properly. I'm taking out all my origin and insertion. I'm going to have my knee joint here. I'm going to have my effort here, my insertion. And I'm going to have my load, which is going to be the bottom of my leg, okay, my lower leg. All right, so what do we see there? We see L, E, F. But we're going and bending upwards. So we really see F, E, L. And FEL is going to be the acronym for FEL, which is going to be a third class lever system. So the lever system is going to be the third class. That's the way you do it. But you have to make sure you're writing this properly. As you can see, when I first started and I put my origin and insertion, that's great to get you started and get your mind right. So I have my origin, I have my insertion here. But sometimes, because that's really close and it's kind of large, people might think, okay, my insertion is then I'm going to have my insertion before I have my actual fulcrum or joint, and then I'm going to have my load. So if I put that here, and sometimes people will say, this is E, F, L. So E, F, then L, right? Going in that kind of direction. But you want to make sure that you're focused on which one's coming first. And yes, that means that you have to kind of look at the actual picture here. I have my knee joint, and then that little dot is going to be my effort, and then I have my load. Kind of have to think about it that way. And this means that if we're going up, this is going to be first, then this is second, then this is third. Okay? Again, just to show you one more time, if I put my E here, and then I put my F, and then I put my load, this is going to make it seem like it's E, F, L, and you're still going up that way. And that would be incorrect. Okay? I just want to show that to just keep it clear. We're seeing our F first. Then we're seeing our effort, which is the insertion point of that muscle. Then we're seeing the load. And again, it comes out L, E, F. But since we're going back this way, we know it's going to be F, E, L. And the only lever system that is going to be the third class lever system. Okay, third class lever system. Is it mechanical advantage or disadvantage? Some folks are just going to remember that, hey, third class is definitely automatically a disadvantage. And then some folks are going to use their load, their effort, and the fulcrum to help them. The load and the fulcrum are further away from each other, so disadvantage. The effort and the fulcrum are close to one another, so disadvantage. So again, this is going to be a disadvantage. All right, folks, I'll see you in the next video. Well, guess what? We get to learn about muscle fiber arrangements, meaning fascicles, and how that can actually aid in movement as well. See you then.